My name is An Chen. I'm a PhD student from the University of Georgia. This is a joint work of the University of Georgia and the University of Virginia. Today, I will present our paper, the SynthDB Synthesizing Database Barrier Program Analysis for Security Testing of Web Application. So let's start with some background introduction. There has been a line of research in analyzing web application statically and dynamically. So for static analysis, they don't have coverage issues, but they have difficulty in handling PHP dynamic features. Therefore, they have a high false positive rate. However, on the other hand, for the dynamic analysis, they suffer from no code coverage. One of the root cause is that they require concrete external resources of diverse content for successful analysis. Among those external resources, the database is the most common one. Okay, so the goal of the SynthDB is to synthesize a test database by analyzing both the target program and the database schema. SynthDB generates a test database with desirable record from scratch that can help cover more program passes with realistic execution context. The generated test database is generic, so they can be used by other existing dynamic analysis tools to improve the effectiveness of the security testing. Now let's look at a motivating example. So this code is borrowed from a real-world application called Schoolmate, which is used for school management. And this is a part of a PHP script that will display a student's weekly schedule. So this statement retrieves all the register codes of a student from the database, and this while loop will check how many courses are registered by that student. If a student registers any courses, this statement will retrieve each course information from the database. And finally, if that course exists, this part will display the student's weekly schedule. Unfortunately, the developer failed to synchronize the data retrieved from the database. Therefore, we have a stored cross-site scripting vulnerability here. So these table definitions are part of a Schoolmate database schema, and this query traces is manually collected when a student with ID 12 interacting with this web application. So basically, there are two general approaches to synthesize a database. The first one is the schema-based synthesizing. So Domino and other similar works, they systematically exercise the integrity constraints defined in the database schema to generate a database. The contents are usually randomly generated. The second one is called the query-based synthesizing. Even SQL and other similar works, beyond analyzing the database schema, they also analyze the query traces to generate a database. However, it is very time-consuming and has privacy concerns to collect the query trace. So for the motivating example, with schema-based techniques, it is they only read and analyze the database schema. Therefore, the quality of the synthesized database is low, as I showed on the left. When the student ID equals 12, running this program with the database on the left, the execution will not access the while loop body. Since the desired value, the student ID equals 12, is not guaranteed in the synthesized database. So the execution will not test the vulnerability. With query-based techniques, beyond analyzing the database schema, they also require the query trace as input. So by extracting concrete value from the query trace, query-based techniques can generate some desired records, which can improve the quality of the synthesized database, as I showed here. Here's another example of the query-based generation, extracting concrete value from the query trace to generate desirable records. So again, with the student ID equals 12, the synthesized database can successfully handle those two select queries. So the two while loop condition will be satisfied. However, the execution would not exercise any of the switch cases because the desired value for the switch cases are not included in the synthesizer database. So which means it also fails to test the vulnerability. So in this paper, we print SynthDB. SynthDB leverages concolic execution engine and data analysis to identify the dependencies between the PHP codebase, the SQL queries, and the database schema and they extract various database constraints from it. These dependencies will be formulated as the various database constraints, which I will explain later, and it then solves those various database constraints to reconstruct a database that will exploit more program passes without violating the database integrity. There are three major components of SynthDB. First, the concolic execution engine will take the application source code and the database schema files as input, then explore diverse program passes repeatedly. Next, the execution trace of the concolic execution will be used by the constraint identifier to extract database constraint from the interactions between the PHP code, the query, and the schema. Here is the database constraint example that the SynthDB can extract it from the motivating example. Later, the database generator will solve all the collect database with SMT solver to synthesize a test database and generate the new input for the concolic execution engine. So now I will talk about all the database constraints that are introduced by SynthDB. The first type is the database constraint. SynthDB checks the type definition, value definition, and the structural keyword to ensure the database integrity. For example, given this table creation query, SynthDB extracts the first constraint by examine the type definition keyword. Here's an example of SynthDB extract another constraint from the value specification keyword. The second type is query condition constraints. SynthDB extracts these constraints from SQL clauses that operate on the query results. So for example, given a select query, SynthDB extracts this first constraint from the join clause. So this type of constraints can provide information on relationship within or across different tables. SynthDB also extracts the constraints from the where clause. So this type of query constraint can provide information on possible value of the database field. The next type is the pre-query constraint. SynthDB extracts constraints from the computation and the practice before the constructing of queries. So for example, before the insert query is constructed, the involved variable u here will go through this string length operation. So this, and then it will be compared to a constant value. So this operation can be formulated as a constraint of the possible value for that database field. So the constant value used in the insert query can also be extracted as a constraint. So the next type is the post-query constraint. SynthDB extracts this constraint by analyzing the program code that are dependent on the query's results. So for example, after the select query is issued, the return variable Q1 will go through multiple operations and predicates, which essentially confines the data value that should be returned from the database through the select query. So as the example shows, this predicate can be formulated as a constraint of the original value of the database field. So the last one is a synchronized query constraint. SynthDB extracts these constraints by analyzing a set of SQL queries that are always executed together. So for example, these two insert queries are always executed together because they are in the same code block. This implies that the involved database fields here are related to each other, so they should appear constantly in the synthesizer database because they are assigned with the same variable. So SynthDB extracts such constraints by analyzing these synchronized queries. So due to time limit, please find more detailed example of the database types and more details about the system design and implementation in the paper. So we evaluate SynthDB with 17 real-world web applications and compare the quality of synthetic database by SynthDB and other state-of-art techniques. We consider category of web applications that the PHP programming language and the database are popularly used, including a management system, online forum, e-commerce platform, and web game. I want to point out that we include some of the popular applications such as WordPress, PHP. We first collect the generated database by SynthDB and the other state-of-art techniques. We then, here the default DB here means the database instance that is set up automatically after the installation. So we then feed those database with the source code to our concolic execution engine. We then measure the code and the query coverage. Our evaluation shows that SynthDB outperforms other existing state-of-art techniques. Database generated by SynthDB achieves 62.9% code coverage, whereas the existing techniques only cover 49% code or less code. SynthDB achieves 77.1% query coverage, whereas the existing techniques only cover 52.9% or less queries. High code coverage does not necessarily lead to high vulnerability coverage. So we also conduct the reachability test against the known vulnerabilities. We collected and manually verified 189 known vulnerabilities from the online vulnerability database and report, such as CVE. Together with the database generated by different techniques, we feed them to the concolic execution and check how many of the vulnerabilities will be reached. So with the database generated by SynthDB, it reaches 80.9% of known vulnerabilities, where the existing techniques only reaches 55.3% or less vulnerabilities. So we conduct additional security analysis using a state-of-the-art vulnerability scanner, Burp Suite, to see how the synthetic database can help the security testing. So we scan PHP web application with the database generated by different techniques, and the result shows that SynthDB can aid Burp Suite discover most of the known vulnerabilities and discover 33 new vulnerabilities from five web applications. So among those new vulnerabilities, SynthDB helps to find 12 SQL injection and 21 cross-site scripting vulnerabilities. We have reported other vulnerabilities to the corresponding vendor, and we receive one CV number so far and with the response for the others. So I would like to emphasize that synthetic database for dynamic analysis is challenging and necessary. So SynthDB addresses by identifying the relationship between the PHP code base, the SQL query, and the database schema. And that will be all. Thank you for listening.
Very so I have a question about your cost. So will you do the evaluation, how will the game backend database implementation go? Is from my perspective, if there's some encoding, decoding involved to the data marks process, you kind of something very fast. So to in this evaluation.
Yeah, the trading with video again.
So when you try to read try to load data from database to engage try to trim out of it. And so EU evaluation we encode decoding processes in the usually code which can help the various patterns.
Yes, here we only track the variables, some of the building functions, but for the others we approximate their relations. So normally we just directly assign the fixed variable to the previous functions, so then we have estimated the connectivity.
The audits, while you're thinking on extra on the sample we need. When you store data to the database, and sometimes there are forward distributions being different. write it up. If user table, user should to a course. So that sheet depends on or so you need to so it imports before you put it up to a human. It's something that it can or is just something that is.
Yeah, the SynthDB handles for each case. So first, we analyze the database schema. If the first case we find in the database schema, we have to look at, we can know the relationship between two tables, two database column, and then actually for the post-query constraints, we also check the return from previous query. If that is used in a next query, then we can identify the relationship between the two queries. So in this way, we can identify the relationship for different tables. Basically, that solves the query issue.
Evan, so you improved quite a lot on firewall, correct? But a little of students here might be interested doing something. Can you give them an intuition of what is the challenge and the really recommending 25% that you will receive? So what are the next big things to be solved?
It's one thing we have not tackled right now is complete constraints. Because imagine for a lot of cases, they have the error content part. They had this less than no return data of database. So basically, I think generate one test base nodes very then complicated for the security test. So in the future, research we generate multiple database for the security test NDSS